Pehla information, the first information that I want to give you is, I don't know whether you know or not, waves are entities. If you recall, in my first class, I told you about the difference between entities and quantities. Entities are something that fills up the universe. If the entities have mass, momentum, etc., they are called as matter, they are in the form of matter. If they have wavelength, frequency, etc., they are called as waves. So entities that you see in nature can be categorized into two groups: material entities and entities who are with wave characteristics called as the waves. So first information is waves are entities. All entities have their own characteristics. Just like material entities, they have the characteristics like their mass, their volume, their density, their momentum, their kinetic energy, their potential energy, their angular momentum. By estimating these characteristics, you have a clear and complete picture of the entity, how it is going to respond in a particular situation. And basing upon that, you will use these entities for different applications. Similarly, what are the characteristics of the wave? How these characteristics can be exploited, and hence the waves can be made useful for the particular purposes. Here, I know very well, you people have some doubt in your 11th class wave. Do you understand what waves are? Do you understand what waves are, any one of you? Is it audible to everybody? Please respond. That's why this class is becoming very day by day.
Yes, sir.
Yes, sir,
Audible.
it is audible.
Then, if it is audible, why you are not responding? Do you
Sir,
know what? Yes. Tell
the
me.
wave it is a form of disturbance.
Where is the?
It is a form of disturbance.
It's a form of disturbance. What you mean to say is, suppose I took my glasses from this place to that place. I made a disturbance in the position. Can I say it to be a wave? You are saying that anything that is in the form of a disturbance is a wave. If that is the thing, then suppose I took this pen from one place to another place, this marker. Can I call this as a wave? I have told you wave is a kind of entity. So how you visualize a wave? आपको वो स्टोरी पता है ना? 7 अंधे हाथी देखने के लिए गए, या पता नहीं है?
Yes,
यस
sir.
सर पता है।
हाँ, आप लोग शायद वेव को इस तरह देखते हो। मैं कुछ सिंप्लीफाइड मैनर में वेव क्या है इसको समझाने की कोशिश कर रहा हूँ। कहीं पे भी आप लोगों को तकलीफ लगता है, you anywhere find any kind of difficulty, please let me know so that I will try to make it clear. First, wave is nothing but a kind of periodic disturbance, oscillating disturbance. So it's a kind of periodic disturbance. Now, you know, when you talk about a periodic disturbance, particularly oscillatory disturbance, you understand that there exists a quantity. That quantity may be displacement, may be velocity, may be electric field, may be pressure. That quantity's value goes on oscillating in between minimum and maximum. Whenever you talk about oscillation, initially in your first two classes, you are visualizing the oscillation of an entity, a particle. But in my discussion of oscillation, I have switched you from the concept of oscillation of a particle to the concept of oscillation of a quantity. So whenever we will be looking at an oscillation, mostly we will try to see what is the quantity that is oscillating. And the quantity that oscillates may be a displacement, may be pressure, may be electricity, may be charge, may be current. Let us represent that quantity by psi for the time. In case charge is oscillating, psi will take the place of charge. In case current is oscillating, as you see in case of AC currents, then psi will take the place of current. In case the displacement is oscillating, psi will represent displacement. Initially, you are representing the quantity who are oscillating by x. Henceforth, I will prefer to represent the quantity who is oscillating by psi. Clear? Is it clear?
Yes, sir.
Yes, sir.
Yes,
So when
sir.
I
Yes.
say where is the kind of
Yes, sir.
disturbance, you will immediately understand that in a wave there must be a quantity who is oscillating. So every wave you look at, sound wave, water wave, electromagnetic wave, whatever wave you look at, you will find there a quantity who is oscillating. Earlier, when we were observing oscillation of a particle, actually what we found a quantity x which was called as the displacement that was oscillating. That means the displacement was a periodic function of time. If that periodic function is sinusoidal, we say the oscillation is in the simplest form. So simplest oscillation, which we call as simple harmonic oscillation. Now, whenever we talked about oscillation earlier, we had discussed the periodic variation of x with respect to time. What I was telling earlier, in any oscillation, there is this quantity which evolves with time, evolves, changes periodically with respect to time. But in case of a wave, what I am saying is, there is a periodic disturbance, that means there is a quantity which oscillates. Then the question comes, the quantity oscillates with respect to what? Is it oscillating with respect to time only, just like this, that represents a single oscillation? Or it is oscillating with respect to something else also? Layman language में अगर वेव को हम लोग एक काइंड ऑफ पीरियडिक डिस्टर्बेंस बोलते हैं, तो वो पीरियडिक डिस्टर्बेंस के अंदर ऐसा एक क्वांटिटी है जो ऑसिलेट कर रहा है. अगर वो ऑसिलेट कर रहा है, किसके साथ ऑसिलेट कर रहा है? आप अगर बोलोगे टाइम के साथ ऑसिलेट कर रहा है, इसका मतलब है साई के पीरियडिक फंक्शन ऑफ टाइम. लेकिन क्या वेव में एक ही वेव में जो क्वांटिटी ऑसिलेट कर रहा है वो सिर्फ टाइम के साथ या और किसके साथ भी ऑसिलेट करता है? इस चीज को भी हम लोग एक्सप्लोर करेंगे. Where is a kind of periodic disturbance or oscillating disturbance that spreads over a region of space? This is another statement that I want to ask. Where, in case of oscillation of a particle, you were focusing on a point which was displacing from equilibrium to and fro. Only on a point. But in case of wave, you know, it is a kind of oscillating disturbance that spreads over a region of space. In this case, don't think that oscillation is going on at one point only. In case of a wave, within a region, everywhere oscillation goes on. Everywhere in that region. So whenever you talk about a wave now, you talk about a region of space which is occupied by the wave, and within that region of space, at every point, there is a quantity who is oscillating. With respect to whom, I will tell you, with respect to whom psi is oscillating. So in case of any wave that you see in nature, it must be spreading over a region of space. Within that region of space, everywhere oscillation of a quantity must be going on continuously. Everywhere, the region that is occupied by the wave where you find that every point oscillation is going on, that is called as the dimension of the wave. In fact, whenever you talk about a wave, you have to visualize a region, not focus on a point only. In case of a single oscillation, you are focusing on a point only. And within that region of wave, there exists a quantity within which there exists a quantity I have named this quantity as psi. I have represented this as psi. Psi may be the displacement as you see in case of sound wave. Psi may be pressure as you see in case of sound wave. Psi may be displacement as you see in case of water wave. Psi may be the electric field or magnetic field as you see in case of the electromagnetic wave. In all ways, you see a quantity which is oscillating. So there is a quantity in which there is a quantity which oscillates with respect to what? With respect to space and time. Both space as well as time. So what I mean to say is, whenever you visualize the picture of a wave in your mind, what we call as physical interpretation, whenever you are able to visualize something correctly, we say you got the physical interpretation. And to visualize anything properly, what you need is you require to sense it. Is it visible everything whatever I am writing on the whiteboard or not visible?
Yes, sir, visible.
Visible, sir.
Okay. Very fine. Thank you. Try to understand the lines that I am uttering. Whenever you can sense something through any of your sense organs, you say it has a physical existence in nature. And whenever you can sense anything physical in nature, you can develop a picture of it in your mind. Then you say you got a physical interpretation of it. So physical interpretation of something can be done only through sensing. As I have told you earlier, science deals with only physical things. It never deals with abstract things what we cannot sense. So whenever we want to picturize or develop a picture of waves in our mind, what we call as the physical interpretation of the wave, we must have to sense the wave. So how to sense the wave? What are the procedures that I am going to tell you later on? But for the time being, whenever you think of a wave, a kind of picture should be developed in your mind like it is consisting of oscillatory disturbances, large in number, spread over a region of space. Within that region of space, there is a quantity which oscillates with respect to space and time. You see, in case of a single oscillation, you are observing the periodic evolution of the quantity with respect to time only. Look at this. In case of a oscillation, you are only observing the periodic oscillation or periodic evolution of a quantity with respect to time only. So with respect to time, there was a periodicity, that's why you could define the time period, you could define the frequency, you could define the angular frequency. Since X was periodically changing with respect to T, so you demanded that after a time interval, X should return back to its initial value. The system should return back to its initial state. The time interval for that is called as time period. Number of times that can happen in 1 second is frequency. Number of times that can happen within a 2 pi second interval is called as angular frequency. This is how you define all these terminologies. So this is the case where you observe the periodic evolution of X with respect to time with a characteristic introduced, that is the time period or frequency or angular frequency, whatever may be. But in this case, in case of the wave, I am not discussing oscillation of one particle only. I am discussing oscillation at many points. In fact, infinite number of points. And all those points are distributed over a region of space. That region of space I visualize as the wave. That region of space I visualize as the wave. And within that region of space, there exists a quantity which oscillates at every point with respect to time. So this quantity must be a periodic function of time, as well as the same quantity oscillates also with respect to space. So what is the meaning of this oscillation with respect to space? That is the extra thing and the interesting, important thing here. If you want to understand the concept of wave, you have to see the evolution of age as well as evolution of that quantity who is varying periodically with respect to time as well as with respect to space. Both the things. Earlier in case of the single oscillation, you are writing X is equal to A sin omega t. So here you are observing only how X is evolving with time. But here the quantity which is oscillating is evolving not only with time periodically but also periodically evolving with space. So both the things you have to look into. So to go into details of it, I am starting with the simplest example that you might have started with the concept of waves in class 9. जब आप लोगों का टीचर लोग आप लोगों को क्लास 9 में वेव के बारे में इंट्रोड्यूस किए, शायद ये एग्जाम्पल से शुरू किए होंगे, उसी को हम यहाँ पे लेके हम आपका वेव का कॉन्सेप्ट को थोड़ा रिफाइन करने की कोशिश कर रहे हैं. So till now, if you have any question, you can ask. Any question from your side?
No, sir.
Very good. Thank you. You take the same example. Do you remember that example? In many of the classes, the teachers normally start with that to understand or explain what a wave is. A stone dropped into the calm and quiet surface of water. Isn't it?
Yes. Yes, sir.
Yes, sir.
Who is the person who wants to come inside? Subhranshu Satwa. 755. It belongs to our section.
Yes, sir. Subhranshu.
Then why he is not coming to keep me like this? Because someone may enter from outside and do mischief. So we have to take care. Okay. ये रोहिना और कौन है? उसको बोलो, जो जानता है उसको बोलो कि अपना क्लिक में लाइव से आए, नहीं तो व्हाट्सएप में वो लिखे, उसके बाद जाके हम देख सकते हैं. क्योंकि वो अगर ईमेल प्रॉब्लम है तो व्हाट्सएप ग्रुप में तो है ना, व्हाट्सएप ग्रुप में आगे पहले वो वेरीफाई करे कि मैं हूँ, उसके बाद जाके उसको हम परमिशन देंगे. देखो Suppose this is the calm and quiet surface of water. Very calm. There are no disturbances. Imagine a situation. This is क्या करें इसको? सत्यव्रत साहू also. सत्यव्रत, are you there?
सर साहू कॉल किया है सर, उसका ऑटोमेटिक लॉग आउट हो गया सर, वो आस्क टू ज्वाइन लिख रहा है।
ओके, मैं एडमिट कर देता हूँ। ओके,
हाँ बोल दो सर कोई।
बट आप चेक कर
मेरा ऑटो लॉग आउट हो गया था सर।
हो सकता है कि कोई बदमाशी करे अंदर घुस के। ये चीज को
सर
थोड़ा
मेरा
आप
ऑटो लॉग आउट, सर मीट में था, ऑटोमेटिक मेरा सर मीट बंद हो गया सर। सर फिर आज
नहीं,
लिखना
ठीक है, ମୁଁ ସେ କଥା କହୁନି, ବେଳେ ବେଳେ କଣ ହୁଏ କି ଅନ୍ୟ
ଆଜ୍ଞା
ପିଲାଙ୍କର
ସାର୍।
ନାମ ଦେଇକିରି ପିଲା ପଶି ଆସନ୍ତି ଏବଂ ବଦମାशी କରନ୍ତି।
Yes, sir, yes, sir.
ହେଲା।
यस सर, यस सर।
So look at this. This is the calm and quiet surface of water. What happens when you drop a small piece of stone at any place? This is a piece of stone. As the piece of stone goes down due to its high density, because of aeration, molecules of different nature, they get attracted to each other when they are closer. So this piece of stone will find water molecules nearby. Due to aeration, these water molecules will stick to the piece of stone. As the piece of stone moves down, the water molecules that stick to the stone, they will also go down. When the water molecule will go down, the other water molecules who are attracting it, because all molecules, they attract each other with molecular forces and remain in equilibrium. So when this water molecule comes down, the distance of that water molecule from other water molecules increases. Due to this, these water molecules start pulling it upward. So there the force acts. These force goes on increasing as this water molecule attached to the stone goes down more and more. And at the point, the force is enough to detach the water molecule from the stone. Stone goes down. Forget about the stone now. What happens to the water molecule? The water molecule moves off because of its restoring force of other molecules nearby. By the time it reaches equilibrium, it gets a velocity. Practically, the velocity, the energy for that velocity has been provided by the stone. Then it overshoots the equilibrium and moves off till its velocity becomes zero. Then again comes down and this way it starts oscillating. So what happens practically? All the molecules that are attached to the stone from all other sides, they start all oscillating. Is it clear? But the intramolecular force it is not one-sided only. If other molecules are attracting this molecule is also attracting the next molecule. So what happens practically? When this molecule comes down, it pulls the second molecule also down. पहला molecule जब नीचे जाएगा ना, तो दूसरा molecule को भी उसके पीछे पीछे खींचता हुआ जाएगा. But the second molecule will start at a little bit later time than the first molecule. So the second molecule will be following the first molecule. It will not be in phase with the first molecule. During oscillation, every position or every state is associated with a phase angle that we have already discussed in oscillation. So what will happen? This will come, attain the maximum. Following that, this will come, attain the maximum. It will go up. This way, the first molecule energy through coupling will be transferred to the second molecule, and little after, the second molecule will be seen oscillating. Are you getting my point? Are you all getting my point?
Yes, sir.
Yes sir।
Yes, sir.
It happens to other molecules also. Now, think of a situation. Think of a situation. Actually, what happens when you drop a stone? the time interval for which the stone remains in contact with water, if that time interval is delta t, and the time period of oscillation of one molecule is t, this ratio is very large. That's why for this interval, the stone being in contact with water molecule, in the first oscillation, the energy is taken from the stone, then that energy gets transferred to the next molecule. But still then, the molecule is in contact with stone, so it acquires more energy. So oscillations are transferring through interaction as well as this molecule is getting compensated. I mean being compensated, the energy is being compensated from the stone till the stone is in contact with the molecule. Then when the stone goes down, after that this molecule because of the transfer of energy comes to rest, then next molecule comes to rest, next molecule comes to rest, but by that time oscillation will be seen proceeding. So to modelize such a situation, let us come to a simplest case. The case is like this: instead of a stone, think of I have a pin or I have an electrically vibrating tuning fork. Think of I am having a electrical vibrating tuning fork. That means whenever you will switch on, the coil of the tuning fork will start oscillating. And put one coil of the tuning fork is being a pin jack, pin, unpin. And the same tuning fork is like this, here like this. So whenever you will switch on, the trend will vibrate, the pin will be continuously tapping the surface of water. Thereby, energy will be transferred from the pin to the molecules continuously. And the molecules there it will start oscillating, the same oscillation will transfer to the next through coupling, next through coupling, next through coupling, and so on. Oscillations will be progressive. Along with that, here oscillations are not going to stop. Why? Because the drum is in continuous oscillation. The oscillation of drum is not stopped. So oscillations will be progressive. Along with that, here also for next oscillation, and so on, the energy required will be compensated by the drum. So what happens? One oscillating disturbance transport, following to that, another oscillating disturbance transport, following to that, another oscillating disturbance transport, just like a train. In a train, what you see? First the engine progresses. Then following to that one bogie, then following to that one bogie, then following to that one bogie. This is why we say trains of waves are progressing. So we are now considering a situation where the source of the wave means the point where the wave has started, is not coming to stop even after the energy from the source is transmitted, because the source is continuously provided with energy for continue its oscillation. उसका एनर्जी आगे बढ़ जाएगा तो ये रेस्ट हो जाएगा, लेकिन उसी टाइम में यहाँ से फ्री आ जाएगा एनर्जी. तो इसी तरह the energy will be compensated to the source continuously, and along with that you will find that disturbances are progressing, oscillating disturbances are progressing one after the another continuously. So such a situation I am going to discuss now. Think of an ideal situation. Suppose there are molecules here in a line. All are connected to each other by through some interaction process, elastic in nature. So this is the line along which all molecules are there. Now, suppose here is the source and the disturbance from source reach here at one instant. एक instant में वो disturbance आके oscillating disturbance आके यहीं पे पहुंचा. इसी पॉइंट को हम Z=0.1 बोलते हैं और ये डायरेक्शन को इस डायरेक्शन में जिस लाइन पे all the molecules are situated उस लाइन को हम Z axis लेते हैं. So what I am doing? I am considering the arrangement of molecules or chain of molecules in a straight line for my simplicity. All these molecules are coupled with each other by spring-like forces, what we call as the intermolecular forces. And the line along which these lines, the molecules are chained, that line I am calling as Z-axis. And taking these points as Z=0, because you know, I have already told you, whenever an observer comes, he first chooses his origin for position as well as origin for time. He is having a stopwatch. The instant he will press the stopwatch, that is the initial time. Now, suppose whenever the disturbance reaches here, disturbance actually has come from source. When it reaches at Z=0, just reach, that time it will just be equal to 0. Means at that time only he pressed his stopwatch. What will happen? This point will oscillate. Let us name this as point 1. So at this point, what oscillation will go on? Assume the oscillation to be perpendicularly taking place to the direction of progressive disturbance. Disturbance जा रहा है Z-axis में, हर पॉइंट में assume करो oscillation उस disturbance का progress की direction को perpendicularly जा रहा है. सोचो एक situation. For your simplicity and developing the picturization in your mind, physical interpretation. Now, at t=0, this particle at 1 is going to start its oscillating. That's just
यार
yes. Anurag, do you have any question?
no sir, sorry sir.
So at t=0, the molecule J=0 has just started oscillation. Now, whenever oscillation is taking place, there is an time period of oscillation. If I look at the time period, you know very well, if there is an oscillation, goes off to the extreme, goes down to the extreme, then return back. This is one time period. So only going up and return back, that is T/2. Then only going to top is T/2. That you understand. If you assume at the starting point, only at the starting point, see, at the starting point, if you take a mean position T=0, then going to one extreme T/4, again returning back to mean position T/2, going to other extreme 3T/4, then again returning to mean position, one time period is over. Then is an amplitude. Amplitude is dependent on how much energy that has been provided to the oscillator, that we have already discussed earlier. Now, at t=0, this particle starts oscillating. What happens at t=T/4? I want to know what happens at t=T/4. This particle, which was initially in this line, Z-axis, this particle will be found at the upper extreme. Within time period T/4, it will be seen moving to the top. The next particle will be seen following it. Next particle will be seen following it. Next particle will be seen following it. There will be a particle number 2, who is going to start just its oscillation. Could you understand this picture? Could you understand this?
Yes, sir.
Yes,
Okay,
sir.
now whenever one oscillation is completed, how much phase angle is increased? That we have discussed earlier. If I write the equation of oscillation as x a sin omega t, if one oscillation is completed, this is the phase, at t, phase is omega t, at t plus one time period, what is the phase? एक ऑसिलेशन में कितना फेज इंक्रीज होता है वो पहले से हम लोग डिस्कस कर चुके हैं. एनी वन ऑफ यू? दैट इज वेरी इंपॉर्टेंट हियर. क्या रे, किसी से आंसर नहीं आ रहा है? ये क्या बात हुआ?
Sir, 2 pi.
यस यस,
2 pi.
2n pi.
2 pi. That we have read that one oscillation is 2 pi phase angle. One complete rotation. Every oscillating particle can be imagined to be a projection of the rotating particle. Whenever the rotating particle completes one rotation, the oscillating particle completes one oscillation. Whenever the rotating particle completes one rotation, the phase travers or the angle of rotation is 2 pi. So every complete oscillation can be associated with phase angle increase by 2 pi. Phase angle increase मतलब E इंस्टेंट की जितना फेज है E प्लस E में इससे 2 pi ये ज्यादा है. ये हम लोग पढ़ चुके हैं, पहले से हम लोग डिस्कस कर चुके हैं. Now when T equal to 0, these particles started its oscillation. So what is the phase here? What is the phase angle here? Assuming the oscillation like that. What is the phase of the particle when the particle is at the mean position and just starts oscillating?
0.
0. So the phase here is 0. After 1/4 of the time period का 1/4 पार्ट के बाद क्या गया? The particle at 1/2 over extreme. So what will be the phase now here?
Pi by 2.
Pi by 2.
Pi by 2, very good. And what will be the phase at 2?
Pi.
What will be the phase at 2? The point 2 is just now starting its oscillation.
Sir, 0.
0.
0. What you observe? At t equal to 0, 0 phase was at 1. At t equal to t at 4, the same 0 phase travels to a new point 2. So you just mark how the phase angle of oscillation is progressing forward along with the progress of oscillation. That you mark carefully. What happens at t by 2? At t by 2, this particle will return back to its equilibrium. Particle number 1. It has already completed the upper cliff, so it will be now starting the lower cliff. The next particle will be following it, next particle will be following it, next particle will be following it, and there will be a particle who will be seen at the top, that is the second particle. जो कि शुरू कर रहा था t/4 में, वो ऊपर एक्सट्रीम में होगा t/2 में. Next particle will be following it, next particle will be following it, next particle will be following it. There will be a particle number 3 who will be starting its oscillation just. So t/2 में पार्टिकल का अरेंजमेंट कुछ इस तरह होगा और बाकी पार्टिकल्स जो है वो ऐसे इक्विलिब्रियम में होंगे. Can you tell me now what will be the phase at 1 at the time t/2?
0.
It has covered half oscillation. You know, when someone completes one oscillation, its phase increases by 2 pi. So if it has completed half oscillation, by how much its phase will increase?
Sir, pi.
Pi, sir.
Pi.
Highest.
So its phase will be pi. You cannot ignore its half oscillation.
Okay,
Here
sir.
it was acting. That's why the phase was given. Now, what is the phase of the particular group?
Pi by 2.
Pi by 2.
Pi by 2. What is the phase actually?
0.
0. Can you mark? At T by 2, the 0 phase was here, now it is here. Pi by 2 phase was here, now it was here, now it is here. At pi phase, at this point the phase has increased. Can you mark one thing interestingly? कोई भी पॉइंट का फेज टाइम के साथ बढ़ रहा है. 0 से 3/2 के बीच में पहला पॉइंट का फेज 0 से 5 तक बढ़ चुका है और जो फेज पहला पॉइंट के पास था एक इंस्टेंट में, थोड़े देर के बाद वो फेज दूसरी जगह पे आ गया है और उस पॉइंट का फेज और बढ़ गया है. नंबर 1 पॉइंट के पास 5/2 फेज था 3/4 में, 3/2 टाइम में वो फेज आके 2 के पास पहुंच गया है, जबकि एक नंबर का फेज बढ़ गया है 5/2 से 5 को. इस चीज को केयरफुली मार्क करो. Whenever the disturbance is progressive, the phase at any point is increasing with time. अगर मैं assume करूं, if I assume that the oscillation is simple harmonic, इसी टाइप का मैं oscillation assume करूं, तो यहाँ पे this is called as phase. Can you tell me at what rate this phase at any point is increasing with time? Phase R T is omega t. Can you tell me the rate of increase of phase with time? How much it is? Tell me.
Sir, omega.
d omega by d derivative of omega t, so this is omega. इसका मतलब जब वेव जाता है किसी भी पॉइंट का फेज टाइम के साथ ओमेगा रेट में बढ़ता रहता है. इसीलिए t इक्वल टू 0 में यहाँ का फेज 0 था, t इक्वल टू t/2 में R1 फेज कितना हो गया? ओमेगा इंटू t/2. ओमेगा कितना है? 2/3 इंटू t/2. dt कैंसिल हो गया, 2 कैंसिल हो गया, 5. इसलिए तो हम लोग बोले कि यहाँ का फेज हाफ टाइम पीरियड के बाद 5 हो गया. आर यू गेटिंग माय पॉइंट?
Yes,
Yes, sir.
Okay. What happens at t equal to 3t/4? Now you can guess it. This is the equilibrium line. So the particle here, it will be seen in the lower extreme. Other particles, they will be following it. Two particles have completed its upper half. Next particle will be following it. Thin number particles at the top. Next particles will be following it. There will be a fourth particle who will be just starting its oscillation. So here phase is 0. Here phase is pi/2. Here phase is pi. Here phase is 3 pi/2. और pi/2 पड़ गया. Now what happens at t equal to t? पहला पार्टिकल एक कंप्लीट ऑसिलेशन कर लिया और नेक्स्ट ऑसिलेशन के लिए शुरू कर रहा है. उसके बाद वाला पार्टिकल इसके पीछे पीछे आ रहा है. ये था इक्विलिब्रियम लाइन. इसके बाद वाला पार्टिकल उसके पीछे पीछे. दैट पार्टिकल 2 इज लोअर एक्सट्रीम. Then like this, like this, like this, our particle reach position and it has completed the upper half. Then and going down, next particle going down, going down, going down. 4 number particle at the top. Next particle going up, going up, going up. 5th number particle is going to start its oscillation. Mark this picture. Can you mark one interesting thing? That is the main motto of today's class that I want to point out. By the time, listen this and try to understand. If you could not follow, you tell me. By the time the first particle completed one oscillation, the disturbance has reached 2.5. I repeat, जितना टाइम इंटरवल के अंदर पहला पार्टिकल एक ऑसिलेशन कंप्लीट कर लिया, उतना टाइम के अंदर एक नंबर पॉइंट के पास जो डिस्टर्बेंस था वो जाके 5 नंबर पॉइंट के पास पहुंच गया. By the time particle 1 completes its oscillation once, the disturbance or oscillating disturbance reach 2.5. Okay, here is the interesting thing. If, listen and tell me carefully, or point 1, if x जो oscillate कर रहा है is equal to a sin omega t. Can you tell me what will be called point 5? X will be how much? ये x1 है, ये x5 है. I should write how much? I assume the energy transfer to be taking place at the same rate, equal rate में. इसके पास से यहाँ से कितना एनर्जी गया, इसके पास से यहाँ तक कितना, यहाँ तक कितना, यहाँ तक कितना. एनर्जी ट्रांसफर रेट डिसाइड करता है एम्पलीट्यूड. इसलिए एम्पलीट्यूड एक पार्टिकल का भी कितना रहेगा, और इसका टाइम पीरियड जो है, क्योंकि ये दूसरे को मजबूर कर रहा है इसको फॉलो करने के लिए, दूसरे तीसरे चौथा सभी का टाइम पीरियड कितना होगा, और साइनसॉइडल रहेगा. लेकिन how much age difference is there between 1 and 5? Can you tell me? How much age difference is there between point 1 and point 5?
2 pi.
Of course, sir. Those who could not understand this, for them, mark करो. एक ऑस्ट्रेलियन एक का कंप्लीट हुआ, अभी जाके 5 नंबर पार्टिकल शुरू किया. तो 5 नंबर पार्टिकल शुरू कर रहा है, मतलब उसका फेज 0 है. 1 नंबर का पार्टिकल एक ऑसिलेशन कंप्लीट कर चुका है, मतलब इसका फेज 2 पाई है. तो if I write the equation of oscillation for the particle 1, it is a sin omega t. Afterwards, ये टाइम के बाद अगर मैं इक्वेशन ऑफ ऑसिलेशन को डिफाइन करके लिखूं a sin omega t, then for point 5 will be a sin omega t plus, yes or no?
Yes, sir.
Could you understand this, or any doubt you will have?
No, sir.
But this is same as a sin omega t, which is x1. So what you understood? Though, please try to understand carefully. Though point 1 has 2.3 more than point 5. Point 5 से point 1 का 2 पाई से ज्यादा है. फिर भी स्टेट ऑफ ऑसिलेशन जो कि डिस्प्लेसमेंट बताता है वो सेम. सो ये एक ऐसा डिस्टेंस है, कितना दूरियां, this distance is such a distance that if you proceed that distance in the direction of propagation of disturbance, disturbance जिस direction में जा रहा है उसी direction में अगर आप इतना distance चले जाओ तो इस पॉइंट में आपको जितना फेज मिला होगा उतना डिस्टेंस के बाद उसी टाइम पे, उसी इंस्टेंट पे इस पॉइंट का फेज 2 पाई कम होगा. और क्योंकि इस पॉइंट का फेज इस पॉइंट से 2 पाई कम है, इसीलिए इस पॉइंट का स्टेट किसी भी इंस्टेंट में जो होगा इस पॉइंट का स्टेट भी उसी इंस्टेंट में सेम होगा. These are two particles. who are in the same state of oscillation because their heads are same, but there is a phase difference between them. The first particle from which the wave came across has 2 pi phase more than that of the second particle. This distance is called as wavelength. Now, if someone asks you, what do you mean by wavelength? आप क्या बोलोगे? वेव जिस डायरेक्शन में जा रहा है, डिस्टरबेंस जिस डायरेक्शन में जा रहा है, उसी डायरेक्शन में जितना डिस्टेंस जाने के बाद स्टेट ऑफ ऑसिलेशन सेम मिलेगा, उस डिस्टेंस को वेवलेंथ बोला जाता है. सो वेवलेंथ is the distance traversed in the direction of the wave after which are the same instant you find the state of the wave, state of oscillation to be same. You see, पहले क्या होता था? एक इंस्टेंट में दो स्टेट है, एक पीरियड के बाद भी t plus t में भी वही है. जब ऑसिलेशन होता है, इंसान में जो स्टेट जो है e plus t में वही है, मतलब x r t a sin omega t x r t plus t a sin
सर
omega
सर
t plus
सर मैम हम लोग की बुला रही है.
हाँ
1-5 हो चुका है सर.
बी क्लास है.
तो बीई क्लास है सर.
बोलो
सर बीई क्लास है सर.
सर नेक्स्ट क्लास से बी का.
Okay, I'm leaving just for 1 minute. So x sin omega t, x t plus t, a sin omega t plus t, and this is equal to a sin omega t. So what you are observing earlier, after one time period, the state of oscillation was returning back. What you observe here, after one wavelength, the state of oscillation is returning back. So state एक वेवलेंथ डिस्टेंस के बाद फिर वही स्टेट आ जाता है जब टाइम आपको फिक्स करते हैं, और जब आप पोजीशन को फिक्स करते हो, स्टेट एक टाइम पीरियड के बाद फिर आ जाता है. सो दैट इज व्हाट आई वांटेड टू टेल यू. हियर देयर आर टू काइंड्स ऑफ पीरियडिसिटी. One kind of periodicity is the periodicity with respect to time, and another periodicity is the periodicity with respect to distance. एक particular distance जाने के बाद state फिर आपको repeat होता हुआ दिखेगा wave की direction में, but at the same instant. This distance is called as wavelength. So there are two periodicity in a wave. One is the time periodicity, giving you the time period of oscillation. Another is the space periodicity after which the same state returns back. That is called as the wavelength of the wave. We will start in the next class from today, whatever we discuss. Tomorrow we are having one class. So bye. If you have any question, you can ask me.
No,
थैंक
sir.
यू सर.
Thank you.
Yes.